Integrated Math 3. This is assignment 2.04. It's called Zeros, Roots, Solutions, X-Intercepts. All those terms mean the same thing. We just call it zeros for short. This is the period 1 version. Since I'm not getting these solutions up until Friday, you have actually until next Tuesday. That's the same time when period 3 turns theirs in. So you can change this to Thursday, the due date, to Tuesday. And that's going to be October 2020. Okay, and that's for both classes. Okay, so let's go ahead and get started. We did most of these in class, or a good number of them, but let's go ahead and do them in case you didn't follow everything, didn't get everything written down. So, what is a zero? A zero is the best description of what it is. It's an x-intercept of a function. It's where it crosses the x-axis. So if I draw over here just a sketch of a cubic function, the typical cubic function you're going to see is going to look something like this. Okay, this point right here, this point, and this point are x-intercepts. It's where they intercept, the function intercepts the x-axis. And those are also called zeros, meaning 0 on the y-axis. They're called roots, or they're sometimes called solutions. Alright, so we're going to go ahead and do these. The importance of these I won't get into too much. I talked about it a little bit with regard to a project I did with a student with basketball where the ground was considered to be the x-axis and the zeros were where the ball touched the ground. But I won't get too much into it. Let's just focus on the math of it here. So the first thing you're going to do here is you're going to factor. And in most of these problems, you're going to need to factor twice. Well, I'll just leave that. So the first thing you do is you look to see if the two terms have anything in common. Here they have an x in common. If you're not sure of that, just write what x to the third means. It means x times x times x. And x, forget the minus sign for right now, it just means x. So what does this and this have in common? A single x. They both have a single x that can be pulled out, that can be factored out. So we'll go ahead and do that. We'll pull that out, x times, and then you have to solve, what do you have to multiply x by to get back to x to the third? That would be x squared. And then what do you have to multiply x by to get back to x? And that would just be x. Excuse me, 1. Okay, so what do you have to multiply x by to get back to x? You just have to multiply it by 1. Alright, so what you have here is something we've seen before called a difference. Difference means a subtraction of squares. X squared is a perfect square. X times x is x squared. And 1 is a perfect square. 1 times 1 is 1. And difference of squares factoring has the form of a squared minus b squared. Okay, so in this case, a is x. In other words, you ask yourself, what squared minus what squared will give you this? That would be an x, and what squared will give you this? That would be a 1. So a is 1, a is x, and b is 1. So we can just go ahead and write that x plus 1, x minus 1. So it's in that same form right there. Okay, in addition to that, we have one more thing. It's the x that we originally factored out. This is this. Now we still have that x sitting there, so you want to put that right there. So a 0, what does a 0 do? A 0, first of all, we now define zeros. So a 0 is a value of x Alright, so 0 is a value of x that makes the equation to go to 0. So before you can do that, you have to set the factored equation that we came up with equal to 0. So when you look at this, there's 3 terms here. If any one of them is 0, it'll make the entire equation go to 0, no matter what the other 2 are. If any one of them is 0 times the other 2, it's going to go to 0. So if we can find what makes this go to 0, that's considered a 0 of the equation. If we can find out what makes this term go to 0, that's a 0. This term goes to 0, that's 0. Okay, so let me rewrite it over here where I have a little space to work. Okay, so to make this equation go to 0, let's start with this one. No, this one's pretty simple. It's just 0. If it equals 0, then no matter what these two are, the entire equation is going to go to 0. If x equals 0, what's going to happen here is that's going to be 0 plus 1 is 1, and that's going to be 0 minus 1 is negative 1. So plus 1 times negative 1 would be negative 1, but it doesn't matter, because if that term is 0, if the x is equals 0, in other words, then the whole equation goes to 0. How about this? So just isolate these one at a time. What would make this go to 0? What value of x would make this go to 0? Well, the answer is negative 1. Negative 1 plus 1 would equal 0. So that's another 0 of the equation. Finally, this one. See if you can do this one. What would make this go to 0? Just this term alone. The number 1. 1 minus 1 would be 0, so this would be a 0. Okay? Now, if I were going to sketch this, I'll do a light sketch. Again, it's not meant to be real exact. It means that the x-intercepts are 0, negative 1, and 1. So that means right here at the origin is a 0, right here at negative 1, and right here at positive 1. So I'm going to sketch a graph that looks like that, except it's going to go through those points. It's going to go up, come down, go back up. So that's generally this, where this is negative 1, this is 0, and this one over here is 1. Okay, 1, negative 1, 0, 1. All right, and so that's it. Now, how do you know it goes like this and not the other way? How do you know it doesn't start at the top, come down, and go down that side? And it's because the leading coefficient in front of the x to the third is a positive number. So it's a positive number. It starts from the bottom of the left side, comes up, curves down, and goes up the top of the left side. That's true of any cubic function. Not all cubic functions go down and come back up. Some of them just come, make a little curve, and go up. But this one actually does curve down and curve back up again. Okay? All right, so that's how you do that. So this is your final answer. Those are the zeros. That's what this lesson is about. Okay, let's keep going. Again, we've done these in class, but it's good to watch them a second time. All right, so you have to ask yourself, what can factor out of this? Clearly you have 3 even numbers there. That means at least a 2. You could at least get a 2 that they all have in common. The fact is, if you know your math, you can see that 6 goes into 6, it goes into 12, and it goes into 48 evenly. So you can factor a 6 out. If you weren't sure how to do that, you can break it into prime factors. So I'm going to show you real quickly how to do that. I'm not going to do it more than just this time. Okay, you can use a factor tree for this. I use that more extensively later in this unit, but factor tree simply breaks it down into prime factors. So what 2 numbers multiply to 6? 2 times 3. What numbers, prime numbers, multiply to 12? And that would be 2 times 2 times 3. And finally 48, the same thing. That's going to be a lot of 2's. It's 2 times 2 times 2. That gets you to 8 times 2. That gets you to 16 times 3. That gets you to 48. Okay? So ask yourself, what do they have in common? Well, they all have a 2. And they all have a 3. The rest of them you see that aren't circled, they don't have in common. This one has 3 more 2's. This one has 1 more 2. But this one doesn't have any more 2's. So you can't say that they have anything, that all 3 of them have anything else in common except a 2 and a 3. So what that means is 2 times 3 equals 6. So 6 can factor out of that because they all had a 6 in common. So we have a 6 here. Now, you got x to the 4th, x to the 3rd, x to the 2nd. Again, you can do the same thing if you need to draw it out like this. So x to the 4th is x 4 times. It's not 4x, it's x times x times x times x. That's different than 4x. This is x to the 4th. Okay, now x to the 3rd is x times x times x, and x squared is x times x. So again, question, what do they all have in common? Well, they have x's here they all have in common. They have x's here they all have in common, but they don't all have another group of 3 x's in either of those places. So it's x times x that they have in common, and that's x squared. So that means you can pull an x squared out. Now you're going to ask, what do you multiply this by to get this? Well, it already has the 6, so you don't have to have that. It has an x squared. You need to get it to an x to the 4th, so you have to multiply it by x squared. X squared times x squared is x to the 4th. Next, what do you have to multiply this by to get 12x to the 3rd? Well, 6, to get 6 to multiply to 12, you have to have a 2. And to get x squared to become x to the 3rd, you need another x. So it's 2x. So 6 times 2 is 12, and x squared times x is x to the 3rd. Okay, finally the last one. Okay, what do we multiply this by to get this? Well, 6 times 8 is 48, so there's an 8 there. And x squared, it already has an x squared. So you don't need to multiply by any more x's, so that's it. So 6x squared times negative 8 is negative 48x squared. Okay, next thing we can do now, we've done a factor. We pulled this out, that's factoring. But the question then is quadratic, can that factor? And usually in these problems the answer is going to be yes. All right, so remember how you do this. You take the let's set it over to the side by itself, and I'm going to place a coefficient of 1 on the x squared term. Okay, and then this is the grand product. That's a times sign, not an x, it's a times sign. So 1 times 8 is 8. So what you have to do is find two numbers that multiply to the grand product, which is 8. And then find the same two numbers have to add to this middle number. 2. Okay, so the grand product is 1 times negative 8 is negative 8. And they have to add up to a 2. So they have to multiply to the grand product, and they have to add to 2. All right, so they have to multiply to a negative number. That means one of them has to be negative and one of them has to be positive. Since they add to a positive number, that means the bigger of the two numbers has to be the positive one. So what I'm going to start is with the small negative number and the big positive number. So 1 times 8 gives you negative 8. And negative 1 plus 8 gives us 7. Well, 7 doesn't equal 2, so we move on. The next number that divides into negative 8 is negative 2 times 4. Negative 2 times 4 is negative 8. And negative 2 plus 4 equals positive 2. That's what we're looking for, to be positive 2. So these are the two numbers. And since there's no coefficient, the coefficient in front of the x squared terms is a 1. That's an easy polynomial to factor. It's simply x minus 2 times x plus 4. Okay, now that's the factor of this. That's the factor of this. But we still have this factor we did at the very beginning. So I'm going to come up here and write this. 6x squared. Okay, so there is your totally factored polynomial this. Now to find the zeros, we set it equal to 0. Okay, and now you have to determine what makes this go to 0. What makes each of these go to 0? 6x squared, what makes that go to 0 is 0. Since it's actually a quartic function, you could say that there are two zeros. You could actually factor that as 6x times x. That could be factored, and you could say that there's two zeros. But when you graph it, there's only one 0, even though you could technically say there's two zeros there. But we're going to just call it 1, 0. That's the way it's going to graph. What makes this go to 0? What value of x? Well, it's 2. 2 minus 2 is 0, so that's going to be a 2. And what makes this go to 0? What value of x plus 4 would equal 0? That would be negative 4. Okay? All right, so there are your values. And I'm going to graph this on Desmos here in a little bit. So we'll see what that graph looks like. Because again, it's not a cubic, it's a quartic. So, but there is your answer right there. Okay, let's keep going. Okay, number 3. Find all the zeros again. You got to factor a cubit. You can see that there's nothing that's going to factor out nicely. This doesn't have an x down here, so it can't be any x term. And you know that 2 and 3 have no factor in common, so it can't be a number. So there's got to be another way to factor this. And we're going to factor by grouping, okay? Remember that name, grouping. You're not going to be tested on the name, but be sure you understand the concept. And the way you can see whether it can be factored by grouping is take the first 2 terms and take the coefficients and make a ratio. Don't worry about the minus signs. Just put a ratio 3/2. Now take these two, 27 and 18, make a ratio of those, 27/18. And 9 goes into both 18 and 27, so if you reduce that down as a fraction, you get 3/2. So since these ratios are the same, you can factor by grouping, okay? And let's see how that works. So we're going to put parentheses around this and around this. Okay, and now what we're going to do is let's take these one at a time. So I've got to pull something out of here that's common. Well, you can't pull the 2 or the 3 out because they don't divide into each other. So you're going to have to leave those inside. But here we have an x to the third, here we have an x squared. And remember how we could say x to the third is x times x times x, and x squared is x times x. So what do they have in common? They have xx, that's x squared. They have an x squared in common. So down here I'm going to pull out an x squared from this. And then inside, what do I have left? I have 2x. In other words, what do I have to multiply x squared by to get 2x to the third? It's x squared times 2x. That's 2x to the third. Over here, I'm going to be left with a 3. And we pulled an x squared out of the entire thing. And that is an x squared there. So what do you have to multiply x squared by to get negative 3x squared? Just negative 3. The x squared is already there, so we don't need to do anything else with the x. So there it is. So that's the factored form of this. Now we're going to do the factored form of this. And on this one, I'm going to put the minus sign, and I'm going to put the x. In this case, what they have in common, we said already, was the number 9. We did that because we said 9 goes into both 18 and 27. Again, if you're not sure, just play around with your calculator. See if there's some common number. This is where knowing your times tables really well helps you, okay? You don't have to mess with the calculator. You can see that 9 goes into that, 9 goes into that. Tricky, because you have a negative sign out there. So what you have is you have negative 18x plus 27. Now I want to group it. I want to wrap a parentheses around like that. But when I do that, it changes. Okay, it becomes this. It becomes negative 18x, because that's negative 18x, negative 18x. But then I have to change this to a minus 27. Because negative negative gives you the positive that's there. So putting the parentheses around it means I'm distributing this negative sign over to this. Whereas before, when it was just written like this, the negative sign wasn't distributed over to that. Okay, so now when I factor this, I pull out a 9, and I end up with negative 9, and then I have 2x here, so negative 9, 2x gives me, will give me the negative 18x that I have up here, and then negative 9 times what will give me positive 27, that would be a negative 3. So that one's a little tricky. When you wrap the parentheses, it changes the sign on the 27. Now let me just pull this down. Okay, and so what we have is this. So what we do is we put our big square brackets around it, just so you don't get it confused with the regular parentheses. It's just another way of saying parentheses. So now we have this term and this term in common. Between these two terms, we have this and this. So this can factor out. So I'm going to bring it outside. And then what do I have left inside the square brackets? I have, so this has come out, in other words, I have x squared minus 9. Okay. X squared minus 9. And this is factorable. Recognize this, start to learn to recognize this as a difference of squares. X squared is a perfect square, 9 is a perfect square, so it's a difference of squares. We've written the formula before. Let's write it again. A squared minus B squared equals A squared equals A plus B times A minus B. Okay, so that means that's going to be, for this, it's going to be x plus 3 times x minus 3. And then we have this term that we factored out, so it's 2x minus 3. So that's the complete factorization of this over here. Now we're going to set this equal to 0 because we want to find zeros. Let's do the easy ones first. What minus 3 gives you 0? That would be a 3. What plus 3 would give you 0? That would be a negative 3. Now this one's going to involve a fraction. It's not that hard. It's just a basic algebra step. So how do you find the 0 for that? You just come down here, you write 2x minus 3 equals 0. And now you just have to know your algebra. I'm going to add 3 to both sides. These two cancel out. And I end up with 2x equals 3. Now I divide both sides by 2. That cancels. And I end up with x equals 3/2. So that's going to be your third 0, is positive 3/2. Okay, again, if I drew a sketched a graph, I'd like you to do that just so you're sure you see what's going on here. I've got a 0 at negative 3, at positive 3, and 3/2 is 1.5, and that's positive 1.5. So it's going to look something like this. So that's what the graph's generally going to look like, where this is negative 3, this is positive 3, and this one in the middle is 3/2. Okay, good. That's it. Let's keep moving. Number 4. Okay, so it says factor each, find all the zeros, one factor has been given. So they've given you a factor. What does a factor mean? It means it divides into the polynomial, So it divides evenly into the polynomial and doesn't leave a remainder. It has no remainder. So let's go ahead and do the division. Let's do it synthetically. So remember what you do when you want your divisor. You take this number here and you flip the sign on it. So it becomes a negative 5. You're going to add your numbers here, and you write the coefficients here. 1, 9, 23, and 15. Okay, you bring down the first number, that's a 1. Negative 5 times 1 is negative 5. 9 plus negative 5 is 9 minus 5. Negative 5 times 4 is negative 20. 23 minus 20 is 3. Negative 5 times 3 is negative 15. 15 minus 15 is 0. This last term is the remainder, and it should be 0. If that truly is a factor, it should divide evenly into this without a remainder. That's what we said that would do. So since it's a cubic here, the answer, the quotient, is going to be a quadratic, an x squared. You bring down this coefficient, it's 1. Then you reduce the exponent by 1, so you just have an x. You bring this down as the coefficient, and then you reduce the coefficient, the exponent by 1, so it means there's no more x, and you bring down this 3. Okay, so there you go. So you have a factor. Now this is the quotient. Now you want to see if this can factor. And in these types of problems, it always will. Okay, that's the whole point of asking the question. So what do we say? The grand product is 1 times 3. So that means it has to multiply to the grand product to 3, that times that, and it has to add to that number in the middle, 4. So let's just take our sets of numbers starting with 1. 1 times 3 is 3, and 1 plus 3 is 4. So that's what we wanted. So the two numbers are 1 and 3. So I'm going to come down here and write this. It's simply going to be x plus 1 times x plus 3. That's for this. then remember they also gave us this one up here. So our entire factor of this equation, this polynomial, is the one they gave us, x plus 5. And that's this totally factored. Now we want to find zeros. We set that equal to 0. And we just ask, what does x have to be here to make this go to 0? These are pretty easy ones. It would have to be -5. -5 plus 5 would be 0. What about this one? -1. -1 plus 1 would be 0. What about this one? -3. So your zeros are x equals -5, -1, -3. Again, let me sketch a little graph. Again, it's going to have that kind of S shape, that sideways S shape. So I have a -5 here, I have a -3 here, I have a -1 there. Space that out very well. But it's going to go like that. Whoops, missed. Go like that, down, and back up again. Okay, where this is -5, this is -3, this is -1 down here. Okay, all right, let's keep going. Okay, this one is kind of the same thing, except there's just one little twist to it. They're saying find all the factors and zeros for that. Now, they're not giving you a factor, they're giving you a zero. What does a zero mean? Well, it's what we just did just a second ago. It means x minus 2 equals 0. So the x for this that would make this go to 0 is 2. So if they give you 2 and tell you that's a 0, then what that means is this that I just wrote here is the factor. That's the 0 that makes this factor go to 0. So if they give you the 0, then you can figure out the factor. It's going to be x minus 2, because 2 minus 2 would have been 0. So that means this is one of the factors. That means it can be divided evenly into this. So again, let's use synthetic division. So what we're going to do then, synthetic division, we take this minus 2 and turn it into a plus again. So this is a plus 2, because that's the way you do synthetic. So I come over here, put the 2 there. And here you have 5, 4, -20, -16. Okay, pull the first one down. 5, 2 times 5 is 10. 4 plus 10 is 14. 2 times 14 is 28. 28 minus 20 is 8. 2 times 8 is 16. -16 plus 16 is 0. So yes, indeed, there was no remainder. That means that was in fact a factor. It does divide in evenly. So what is our polynomial? Well, we started with a cubic, x to the third, so our first term of our quotient is x squared. You reduce by 1. Here's the coefficient there. Then it goes to x. There's the coefficient there. And then it's plus 8. So now we know one of the factors was this. Now we're going to factor this to see what the other two are. So this is the one that's a little more complicated. We did this in class on Friday, for those of you that are in third period. So you have 5 times 8. The grand product is going to be 40. So we need to multiply to be 40 and add to this middle number, which is 14. Okay, so now you're just going to take a sequence of numbers that multiplies to 40 and adds 14. Since they're both positive numbers, the two numbers are going to have to be positive. So we're going to do 1 times 40 equals 40, and 1 plus 40 equals 41. That's not what we're looking for. Now we go to 2. 2 times 20 equals 40, and 2 plus 20 equals 22. That's not what we're looking for. We're looking for 14. How about 3? 3 doesn't go into 40. How about 4? 4 times 10 equals 40, and 4 plus 10 equals 14, and that is the one that we're looking for. So these are the two numbers we're looking for here. So what you do is you come over here and you take the 5x, not the 5x squared, just the 5x, and put it over 4. and then take 5x again and put it over 10. And see if either of those reduces. 5 over 4 doesn't reduce. So your first binomial for this is 5x plus 4. And this one reduces to 1 over 2. So that's 1x over 2. So that's 1x plus 2. Or just x plus 2 is fine. So that is this factored. And then we already learned that this up here was a factor. So now we put all three of these together. We'll do that over here. So it's x minus 2, 5x plus 4, and 1x plus 2. Okay, so what makes these go to 0? Well, x plus 2 equals 0 if x equals negative 2. X minus 2 goes to 0 if x equals 2. Now this one's more complicated, but we did this in class. Let me show you how to do it. You just set this equal to 0. So I'm going to come up here where I've got some space. So 5x plus 4 equals 0. And now you just do the algebra to solve for x. Subtract 4 from both sides. And you got 5x equals 4. 5x equals negative 4, excuse me. Then you divide both sides by 5. Cancels, and you end up with x equals negative 4/5. So this is negative 4 over 5. Okay, so your final answers are x equal to negative 4/5 and negative 2. Okay? Alright, let's keep going. 6. Okay, 6 is called the remainder theorem. It's, again, except for the very first step of each of these problems, you end up doing the rest of the problems exactly the same. So what the remainder theorem says is, if you plug this into the function, so it says plug that number, that's what f of 1 means. It means you take the 1 and put it where the x is, so anywhere you see an x, you put the 1. So plug 1 into the equation plug 1 into the equation and see if it equals 0. If it does, then that means that this is a 0. It is a 0, which means we can turn it into a factor the way we did on a previous problem. Let's first of all see if it does. So what you're going to do is take 1, so it's x to the third, so that means 1 to the third, plus 5 times 1 squared, it's a parenthesis, plus 2 times 1 minus 8. So 1 cubed is 1, 1 squared is 1 times 5 is 5, 2 times 1 is 2, minus 8. 5 plus 1 is 6, plus 2 is 8, minus 8 equals 0. So that means 1 is a 0. And if 1 is a 0, then the factor must be x minus 1. Again, why is that? Because what makes this factor go to 0? If x equals 1. So that 1 we determined is a 0. So this is going to be the factor that's associated with that 0. It's x minus 1. That means we can divide this into our polynomial, and we can it should come out to be no remainder because it is a factor. That means it divides in evenly. So let's do that using synthetic division. So I have x minus 1. That means I need a positive 1 for synthetic division. You just switch the sign on that. And then I have x to the 1x cubed is 1, 5x squared is 5, 2x is 2, negative 8. Okay, you bring down the first one, becomes a 1. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 2 plus 6, that is a 2. Let me be clear on that. 2 plus 6 is 8. 1 times 8 is 8. And negative 8 plus 8 is 0, so indeed there's no There's no remainder there. So now we go ahead and form our quadratic. So we started with a cubic x to the third, so our quotient is going to be an x squared. You always go down one exponent. Bring down this coefficient as 1 plus 6, and the next one's going to just be x. You just reduce that by 1, and the next one is going to be 8. Okay, so now I'm going to factor this. So I need to multiply to the grand product. That's 1 times 8. 1 times 8 is 8, and it has to add to 6. Okay, so everything's positive numbers, so we just deal with positive numbers here. 1 times 8 is 8, and 1 plus 8 is 9. That's not what we're looking for. 2 times 4 is 8, and 2 plus 4 is 6. That is what we're looking for. So 2 and 4 are our numbers that we're looking for. So again, there's no leading coefficient except the 1 there, so it just simply becomes x plus 2 times x plus 4. So that's this factor. But remember, we have another factor right there that we figured out at the beginning. Okay, so we're going to write that out as x minus 1 times, and we come back down here, x plus 2, and down here again, x plus 4. Okay, and that equals 0. So again, just ask what makes each of these go to 0. What minus 1 equals 0? That would be 1. What plus 2 equals 0? That would be negative 2. What plus 4 equals 0? That would be negative 4. So there are your zeros. Again, if I'm sketching a graph, negative 4 is here, negative 2 is here, and positive 1 is right here. So it's going to look like this. Like that, okay? Okay, all right, there we go. Let's do one more here. A couple more here, actually. Okay, here again, we're going to use the remainder theorem. We're going to plug this 2 into here. And if it comes out to be 0, that means this is a 0. And the factor for that, if it was a 0, would be x minus 2. What minus 2 equals 0? It would be 2. So that's the 0, that's the factor. If this does not turn out to be 0 when we plug this in, we can't create a factor, and therefore we can't solve the problem. So we're done with the problem. So let's go ahead and plug the 2 in here. So it's 2 cubed, that's this right here, minus 2 times 2 squared, that's this term, plus 9 times 2, that's this term, and then minus 10. So 2 cubed is 8, minus 2 squared is 4 times 2 is 8, so it's 8 again. 9 times 2 is 18, minus 10. So 8 minus 8 just goes to 0, plus 18 minus 10 equals 8. So this does not equal 0. Therefore, that is not a 0, and that is not a root. So there's nothing you can do at that point. You can't factor it. If it was possible to do this by grouping, you could, but that's not a factor by grouping. This is a 2-to-1 ratio. 10 over 9 is not a 2-to-1 ratio, so you couldn't factor it by grouping. So you're done with the problem, okay? So 2 is not... 2 is not a 0. That's basically the answer, so you can't go any further. Okay, I'm going to wrap this video, and I'm going to do the Desmos on a different video. I don't want this to get too much closer to an hour, so I'll go ahead and publish this for you, and then I'll do the Desmos on a separate video a little bit later.